Hello everyone, welcome back to another video of our multi-threading in Java series. And in this video, we will be looking into something very important and very confusing for many Java developers, which is Callable and Future. In this video, we will learn why Runnable is not enough for threads. We will also learn what is Callable and Future and what problems do they actually solve. Then we will learn how was Callable and Future designed, and we'll also see a small example involving both Callable and Future. Right, so without wasting any time, let's start. Let's start from the basics. In Java, a thread cannot execute just any code, right? A thread needs a task and that task must be represented as a runnable. So this is how the runnable interface looks. So whenever we create a thread, we do this. We create a class that implements runnable and overrides the run method of the runnable interface. So in short, this is how you do using lambda expression, correct? So you have created a runnable and then you pass that runnable into the constructor of thread class and thread.start, right? So a new thread will be spawned and whatever is present inside the run method, that is executed. Correct? So the conclusion is a task will only be executed by threads if it is implementing the runnable interface and overriding the run method, right? Now, what are the problems or limitations of runnable? Let's see one by one. So the first limitation is runnable's run method itself. So runnable's run method does not have a return type. It returns void, means nothing. Right? So what if my task calculates a number or fetches data from a DB or calls an API and I want to return the result of that operation back to the caller or the main thread, right? For example, suppose I have done this, I have calculated the sum and I want to return this sum. So can I do this return sum? I can't. Why? Because the return type itself is void. So how will I return it? This is a limitation, right? So to overcome this limitation, we are forced to use either a shared variable or mutable objects, which leads to messy code, thread safety issues, and which you have to handle using wait and synchronized both. Correct? Now the second limitation with runnable is exception cannot be caught by caller. What do I mean by this? Right? So consider this example where I have a runnable and inside the run method, what I have done, I have simply thrown an exception, correct? So I have passed that runnable in a constructor and I have done thread.start. So what should happen? Inside this try, if any exception occurs, it should be catched using this catch block, correct? So if I write thread.start, internally this run method will be executed. This run method is throwing an exception. So this exception will be caught by this catch and what will be printed? Our output should be exception thrown. Now let's go ahead and run this program and see what the output is. So if you see the output, the issue here is exception thrown is not printed. Rather, whatever exception you have thrown, that stack trace is printed inside the console, correct? So this exception is not being catched by the caller, by the main thread which has actually executed the thread, correct? So what is happening here is run executes in another thread and exception is thrown in that thread. Now try catch is present in the main thread and exception do not cross thread boundaries automatically, correct? So what happens here? The worker thread or this thread dies, stack trace is printed on the console, but the caller or the main thread has no idea that the task has failed. Now this is very dangerous in real systems. Why? Because if the caller doesn't know that the task executed in one of the threads has failed, then the caller cannot retry, it cannot fall back, and it cannot even log the error properly, correct? So Runnable has two major problems. The first problem is it cannot return a result and the second problem is it cannot report exceptions back to the caller. And that's exactly why, my dear friends, Java introduced Callable and Future. So Java's combination of Callable and Future solves both these problems. Now, before diving into Callable and Future implementations, let's try and solve these problems ourselves. So let's get on our IDE and try to solve these problems by designing the class ourselves. Okay. So before moving forward, let's see how the future interface looks, right? So if I write future here, if you go inside, you will see future is an interface which contains lots of methods, right? Also, if I go inside the executor service and I type submit inside it, right? The submit is actually used to submit tasks to the thread pool. So if I see this function, if I go inside the implementation of this, I'll see. So I have a return type of future. Inside it, I have a runnable future. Now if I go inside this method, I can see I have a future task here. This future task, it implements runnable future, and runnable future extends runnable and future, correct? So there are lots of interfaces, lots of classes, and lots of functions. But don't be scared, I'll make this very easy for you, right? I just wanted to show you the complexity of future, and now you will see how I will break it down very simply for you. So let's close these tabs and let's remove this future. So let's try to solve the limitation of run method that we just saw. So what was the limitation of runnable interface? So runnable interface has run method which does not return anything. So if you want to return anything, let's first create an interface that actually returns something, right? So let's go ahead and create an interface named myCallable, correct? Inside myCallable, we will solve two limitations of run method. First is it cannot return anything. So we will write int compute. We will create a method that actually returns something, and then run was not able to throw an exception. So let's go ahead and make this method to throws exception, correct? So this is our function definition that we have created in this interface, correct? Now we also saw that thread cannot execute any random class. It needs a class that actually implements runnable, correct? Then only it will able to execute that in a thread. So let's go ahead and create a class. Let's name it return runnable. Right? So we are trying to create a class that actually returns something, but it needs to implement the runnable interface because we want it to be executed by thread. So first let's go ahead and implement runnable here, correct? Implements runnable, and let's go ahead and implement the run method. Now what we will write inside the run method? We have to return something, correct? Now if we have to return something, we cannot return using run because it does not have a return type. So we have created an interface, right, called myCallable. So let's go ahead and write here myCallable, correct? And then let's create a variable where we will actually store our computation, and then we will return it using this class, correct? So let's go ahead and write this as result, correct? Now also let's go ahead and create a constructor, and this constructor will only be for myCallable class, correct? Now inside our run method, what we'll do, we will write myCallable dot compute, and since this compute actually throws an exception, so we'll have to surround it with try catch, correct? That's it, and we'll write here this dot result equals to myCallable dot compute, right? Okay, so what have we done here? So we have created a class that implements runnable because we want this to be executed by thread. Then we have made use of the myCallable interface that we have just created, right? The implementation of compute method inside the myCallable interface will be provided when we create an instance of this class using this constructor, correct? So the run method, what it will do, it will go ahead and execute the compute method of my callable class, and whatever integer, whatever result that my callable will return, we have assigned it to this dot result. Now we definitely need a method to get this result back, right? We have just assigned it. So let's go ahead and create a getter for this, right? So public int get result return result, right? So this is a getter that we have created. Now what we need to do? Now inside our main class, the first thing we will do is we will go ahead and implement our compute method, correct? So we'll write my callable equals to new my callable, and we'll go ahead and override the compute method. Now since compute method returns something, and what it returns is it returns an integer. Let's return 10 from here, correct? So we have returned 10. Now what we'll do, we'll create an object of type runnable, I mean the class which implements runnable, correct? So return runnable new runnable, and what will pass? Will pass whatever my callable object which is there, because the constructor expects a my callable object, correct? Now this runnable will go ahead and pass it into the thread constructor. Thread equals to new thread, and we'll pass return runnable here. Then we'll do thread dot start post that, we'll write thread dot join so that our main thread waits for the this thread to complete, and post that we'll go ahead and print our result, whatever result we have. System.out.println. Now where is that result stored? That result will be stored inside this result variable, correct? And we'll get this result using get result method, correct? So system.out.println result is, what is the result? Return runnable dot get result, correct? Now for more clarity, let's go inside return runnable and write here system.out.println result is set by an thread dot current thread dot get name. So whichever new thread is created, just for verification that whatever logic we are writing here is executed in new thread, that is why we have printed this, correct? Now let's go ahead and run this. If I go ahead and run this, I'll see the output. Result is set by thread 0, the separate thread which was created apart from the main thread actually executing, which is thread 0, and the result is 10. So we are able to get something which is run by the thread, and we have devised a method such that we are able to get something from the thread. And what we are getting? We are getting an integer from that, correct? Now it doesn't need to be integer, right? So we can return a string, we can return an object, we can return anything, right? So what is our next step? Our next step is to go ahead and make the my callable interface generic. So instead of integer, we will return t, correct? Here also we'll go ahead and write t, so it returns generic type. Inside return runnable as well, my callable, this is fine. Result, this will be generic. Runnable interface, it will have t. Then what we can do, yeah, so this will also return a generic, correct? And here also at the time of initialization we need to pass t, and here also we'll have to write t, correct? So we have written t everywhere. Now let's go in our main class. In our main, what we will do, right? So if we want to return an integer, we'll write integer here, and here also we'll write integer, correct? What we'll do here, we'll do t integer and this, correct? Now let's go ahead and run this. Our output should remain the same, correct, which is 10. Now since I have used generics, if instead of integer I want to return a string, I'll just write string here, do the same thing here, string here as well, and I'll return maybe hello world. Correct. So everything remains the same. I have just changed these values to string. Now if I run this, so now our thread is capable of returning a string as well, right? So we have made our my callable interface generic. Correct. Now you can see what is the purpose of this return runnable class. This return runnable class is responsible for running the logic of the thread as well as returning the result. Now let's separate these two things, right? So return runnable should only execute something, and the other concern, which is about returning the result, let's separate it from return runnable. Let's decouple those things, right? So for that, let's go ahead and create a class named my future, or interface, sorry, interface my future. And inside this my future, I will return a generic, and it will have a get method, or we'll see, let's say get result method. Correct. This is there, right? And inside our return runnable, we'll go ahead and implement my future, and this remains the same, right? Now this get this is overridden. Correct. Now this get result comes from the my future interface that we have created, right? So we have decoupled the logic of executing whatever is present inside the run method and returning the result whatever has been stored. Correct. Now if I go ahead and run this, I should get the same output. Correct. Now everything works fine, right? So you saw how step by step we first created our my callable interface. Correct. Then we created our return runnable and implemented runnable interface because it needs to be executed by thread. Then we made it generic by using T everywhere, and post that we separated the actual returning of the result from this return runnable by creating a new interface named my future. Now this is exactly how callables, future, runnable future, whatever you have seen is designed in Java. Correct. Now if I correspond it to the actual classes, so we have created this so easily, right? Now if I correspond them to the actual classes and go on our Blackboard and see, so on the left side you can see our classes that we have actually created in this example, and on the right side you can see the actual classes to which our created class corresponds to in reality. So we have created my callable. This my callable corresponds to the actual callable class that is present in Java. The my future class that we have created, that corresponds to the future interface of Java. Correct. The get result method that we created, that corresponds to the get method present inside the future interface. And along with this get method, future interface also has some more method, which is done, cancel, is cancelled. We'll see what this method means, but the classes corresponds like this, right? The return runnable class that we created, that actually corresponds to the future task class in Java, and it implements runnable, implements my future. In Java, there is one level of abstraction as well. So these two are combined in Java, and it is written as future task implements runnable future. Correct. And this runnable future in turns extends runnable and future, which we have done here directly in our example, right? So this is one level of abstraction that Java has. So now you know what was that future class, what was that future task class, what was the runnable future that we saw, what is callable. Now everything is corresponding to a simple example that we just created it. So this is the structure. The Java just has some more methods and more functionality associated with it, like these more methods as well as exception handling and everything. Correct. Now if I go back to IntelliJ inside this fix thread pool, and now if I write future, now you are not scared of this future interface. Correct. Because you know that future interface, we have already implemented this get method, right? We have some more method like get with different parameters, is done, is cancelled, cancel, all those things, correct? Same thing if I go inside the executor service, I show you the submit method. Inside the submit method, what you do, you pass a callable. What is callable? Callable has a call method which is corresponding to our compute method. It is a generic and it returns an exception. Same thing that we did, correct? Now inside this implementation of submit method, if we go, we have a runnable future, correct? And this runnable future extends runnable and future. In our case, return runnable was implementing runnable and future, correct? So this is okay, fine. Now let's see how Java's actual callable and future work with executor service. So I have a fixed thread pool of 3 threads, correct? What I have done, I have created 3 different classes that implements callable and returns an integer, correct? So this first class, after 3 seconds of sleep, it returns 30. Now the second task, after 1 second of sleep, it returns 100. And the third task, after 2 seconds of sleep, it throws a runtime exception, correct? Now here what we have done, we have started submitting the task to this thread pool using the submit method, because the submit method needs a callable task and we have already created the callable tasks here, correct? So we have created new task 1, new task 2 and new task 3. We have submitted this, and what do we want in return? We want a future object in return, because this submit returns a future. So we have written this future and we have written the return type of the result that we want it to be returned, right? After that, I have printed 10 times I am not waiting for the results. This is written in main thread. So all these tasks will be submitted. These 3 tasks will run in parallel. Meanwhile, the main thread will not wait for results. It will go ahead and execute whatever is present after these 3 statements, correct? So it will print I am not waiting for results 10 times, and then inside the try catch we are trying to get the result using the future object. So future1.get, future2.get and future3.get, correct? So let's go ahead and run this and see our output. First we have printed main thread submitting tasks, correct? So all the tasks have been submitted. Task 1 has started on pool 1 thread 1. Task 2 has also started, and parallelly main thread had started printing I am not waiting for results 10 times, correct? And then task 3 was also started. It got printed later. And post that, when I wrote future1.get, here's the very interesting part. So I am calling future1.get first. So task 1 has a 3 second of sleep and task 2 has only 1 second of sleep. So by the time the main thread reaches future1.get, task 2 has already been finished, but we haven't collected its result yet, right? The result of task 2 is sitting inside the future object that we have created, and as soon as we write future2.get, we will get the result for task 2. So what you will see when I go ahead and run this, so let's go ahead and comment this first. Now one more important thing here is the .get method. The .get method is a blocking operation, correct? So this is a blocking operation. So even though task 2 has completed and task 1 is not completed, once you have called future1.get, then it will wait for as long as task 1 gets completed. If it doesn't get completed, the main thread will not move forward, right? So it is very important. When you submit a task, the task is submitted and those tasks are run parallel. Post that, main thread can also work in parallel. But as soon as you want the result back from those threads, back from the future object, and you write future1.get, now future1.get is a blocking operation, right? So if I go ahead and write this 10,000, right? So our thread will wait for 10 seconds, even though the task 2 has completed, because the wait time is only 1 second. Then also, since task 1 takes 10 seconds to complete, this future one dot get will wait for 10 seconds. It is a blocking operation. Then this will be printed, right? As soon as you write future 2 dot get, the result is already ready and sitting inside the future. So immediately this will be printed. And about the future 3, let's go ahead and run and then talk about the future 3. Correct? So if I run this, correct, 3 tasks are submitted. Now we are waiting for 10 seconds because our main thread is blocked on this line. Correct? So yes, so as soon as 30 is printed, immediately task 2 was ready. So task 2 also got printed, and post that a task failed and reason something went wrong in task 3 is printed. So what is happening here? When you wrote future 3 dot get, task 3 actually threw a runtime exception. If you see here, after 2 seconds, task 3 threw a runtime exception, and the error was something went wrong in task 3. So when you wrote future 3 dot get, the exception doesn't crash the main thread silently, right? It crosses, the exception crosses the thread boundary, gets wrapped inside the execution exception, and is delivered right here to our catch block. So the exception thrown by our callable is saved inside the future, and as soon as we write future 3 dot get, that exception is caught inside our caller and a valid error message is printed, right? So we know exactly which task failed and exactly why it failed. So there were 2 limitations of Runnable. The first one was we were not able to get the result back, and second was we were not able to propagate the exception back to the caller, and both of the things are being solved here using Callable and Future. Correct? Now apart from dot get, there are 3 very important methods inside the future interface, which is done, cancel, and is cancelled. So if you write future dot is done, it returns true if the task is finished in any way, whether successfully or whether with an exception or whether it is cancelled. So it just means that task is no longer running, right? So don't assume that if is done equals to true, that means it is succeeded, right? So it means the task is no longer running. Correct? Now cancel. Now cancel, it attempts to cancel the task. Now this parameter is very important. So if you pass true inside this cancel method, then it will send an interrupt signal to the thread if it is already running. Correct? Right? If it is already running, then it will send an interrupt signal. And if you pass false, then it will only cancel the task if the task hasn't yet started. If the task has started already, then the cancel will have no effect. It will just return false because it is too late for the task to be stopped because it has already started running. But if it has started running and you still want to stop that task, you can ask it politely by passing may interrupt if running boolean, which is true. If you pass true, then it will send an interrupt signal to the thread, right? And it will attempt to cancel the task. Why? Because interrupts are not forceful. Interrupts are polite way of asking the thread that whether you can stop or not. If you can stop, then please stop. And I have covered interrupts in my previous videos in complete detail. I will link the interrupts video in my description as well as on this video as well. So you can go ahead and watch that interrupt video. It is very important and in very detail. Correct? Now the third is cancelled. Is cancelled only returns true if the task was explicitly cancelled via the cancel function. Correct? So a task that failed with an exception is not considered cancelled, right? So if a task has failed with an exception, then is cancelled will be false, but is done will be true, right? So this distinction is very important between is done and is cancelled. Correct? Apart from this, I want to show you one more thing. So here our future one, I mean the task one is taking 10 seconds to complete. But what if you only want to wait for 2 seconds, right? So if I write here 2 time unit dot seconds, add exception to method signature, correct? So it will wait for 2 seconds, and if in 2 seconds result is not returned, let's go ahead and see if the result is not completed and you are waiting for 2 seconds, right? So after 2 seconds, what it will print, correct? So if I go ahead and run this, after 2 seconds, if that is not completed, if the task is not completed, then it throws a timeout exception, correct? It has waited for 2 seconds and then it has thrown timeout exception, and that itself is printed on the console here, correct? Right, so I think we dove into details of Callable and Future, and that's it from my side. I hope you all liked this video. Please share this video as much as you can, and please subscribe to my channel. That's it for this video. Until the next video, stay safe, stay healthy. Bye bye.